As an alternative to TCP-based socket applications, you can create UDP-based datagram applications. The User Datagram Protocol, or UDP, does not guarantee the delivery of its data. The advantage of using such a protocol is that it does not consume as much bandwidth as TCP, since no packets need to be sent back and forth between client and server simply to verify that data is transmitted and received accurately. The disadvantage is obvious. The client and server can't be sure if the data actually arrived at its destination intact. Examples of uses for UDP-based applications are projects like streaming video servers or internet radio stations. In such a situation, if packets or frames are lost during the broadcast transmission process, it has minimal impact on everyone involved. To implement UDP connections, Java provides the DatagramSocket, DatagramPacket, and MulticastSocket classes. DatagramSocket objects are used to create sockets through which UDP traffic can pass as DatagramPacket objects. When using DatagramSockets, the server waits for the client to make a request. Once the client makes this request, the server sends its UDP traffic via Datagram packets to the client. All communication happens in a one-on-one fashion between client and server using this method. Here's an example of a simple project that uses DatagramSocket and DatagramPacket class objects. So first we'll take a look at the server, and notice what we're importing: IO, net, and the utilities packages. Here's our class. It's going to be called "single server," and later we'll do another example using Multicast. We have a global Datagram socket called sock, an integer quote count, and we have an array of strings here. And these are just quotes that we're going to serve out via socket. This is very simple, UDP connection, and we'll serve out string quotes. Okay, so in the main method, it's simply building an instance of the class, and our class, notice that it extends thread, therefore it has to implement the abstract method run, and it's doing that when it calls the start function here. Since it is extending thread and it's a thread object, then that's just going to cause the run method to run and execute. So that all happens inside of main, and remember that gets called first. Well, what happens even before that is our constructor would be called. So in this case, here's our global Datagram socket up here, sock. Well, we're going to instantiate or build it. And we're going to listen on port 444. And then we're just going to display some status information. There's no graphical interface for the server here, so it's just going to display it on the console. Launched quote of the day, server thread waiting for client to connect. Okay, so once the constructor has been called, since the object was built, and then we call the start method, which calls the run method, then this is going to happen. So let's take a look at what happens inside the run method. While true, we have sort of an infinite loop here until something happens that would cause us to exit the loop. In other words, we shut the server down, or we could pass in some kind of signal value. But for now, it's just pretty much an eternal loop. Okay, so we have a try and a catch, and remember, just as with socket class objects, when we use multicast socket and when we use Datagram socket objects, they need to be enclosed inside of try and catch blocks, or you would need to throw an exception, the appropriate exception. In this case, an IO exception. But so in our try block, what are we going to do? Well, we're creating an array of type byte in this case, and it will be 256. That will be the size. And we need this as just sort of a buffer, so we call it buffer. And then we're going to instantiate or build a new Datagram packet, and we'll call it packet, since that's what it is. And we're going to pass in buffer and the length of the array, the number of elements in it, and buffer that length. When we do this, now we're going to listen. In this case, we'll receive a packet. All right, so we're waiting for someone to connect. Our server's waiting for somebody to connect, the client to connect to it. When it does, we'll receive it. And then once we do this, then we can actually go and do something with the information that gets streamed to us over UDP via our Datagram socket using our Datagram packet. So we're going to go call the next quote method and assign the return value to message. Now, remember that sock here is global. It's way up here at the top. So we can use it in any function in our server without having to pass it as an argument. Alternatively, if you don't like the globals, you could recode it so that you're just passing it as an argument if you want to do that, since things are passed by reference as a default in Java. But in this case, it's a global, so we can just go call next quote, but we will be making use of that Datagram socket. Alright, so once we do this, again, our global up here, DatagramSocket sock, was being used and run. Now we've called next quote, so now it's also going to be used inside of next quote, but we have a string. We're going to generate a new date object, and we're going to get the count, the number of quotes, right? In other words, the number of phrases of strings in our array of type string, and that -1 for, to offset for the fence post or the off by 1 issue. But if we've gone more than the number of quotes we have, we're just going to display, hey, we're fresh out of quotes, mate, have some time. We're going to convert the date object to a string and display that. And then we'll display in the console here, well, this is what would be streamed to the client, and this is what will be displayed at the bottom of the console application. So client output, and this would be here, I'll highlight it, would be server output, right? All quotes were served, dishing out some time. Okay, if that's not the case, if we still have some quotes left, then what happens? Well, message is going to concatenate the quote count and then a number, so we can number it and see what quote numbers are on, and then it's going to take our string and the index or subscript value and pull out the right quote going through all the elements in our array of type string. And that would be sent to ultimately the client. And then this would be displayed at the server here, in the console, serving out quote numbers. So this way we can confirm and we can kind of look and see that the client gets a quote number, and we can see what the server is serving that quote number. Anyway, regardless, whatever has happened, the if or the else, we're going to return message, right? It's a string. We're going to return a string value. Remember that, program flow stopped here. When we got down to here, we instantiated a DatagramPacket. We had a DatagramSocket. We were receiving, using that packet, and then we went and we called next quote. And based on the value of our global counter object, we pulled one of our quotes out from our array of type string. So we're all done with that. That's assigned to message, and then what happens? Well, in this case, we're going to get the bytes. We're going to get the actual byte size of message. We're going to assign that to buffer. All right, here's our buffer here, array of type byte. Now we're going to build an inet address object, and at this point, you'll notice things look a little bit different than when we were using just plain old TCP sockets, like in our previous projects. All right, so we build an inet address object. We're going to call it IP address because that's what we're going to use it for. And we want to get the address, the IP address of the packet, okay, that came in. Remember that our packet up here is this datagram packet. And then once we do that, we're also going to get the port, calling the get port method. So we call get address to get the IP, assign that to the, IP address will hold that, and we're going to get the port, and that this integer will hold the port. So now we're going to take our packet and we're going to instantiate or rebuild the packet. So we're going to build a new packet, calling the keyword new DatagramPacket, and passing in buffer length, the IP address, and the port. And then we're going to, in this case, send via UDP traffic out of our socket, in this case our DatagramSocket up here, way global socket up here, DatagramSocket socket, remember? We're going to send that out and back to the client, all right? And so it would be the quote, unless of course we ran out of quotes, and then it's just going to be the time, okay? And that's, this is going to happen every time a client connects. Then that client will be able to, it'll be issued a quote. Once it makes the request, it's going to listen for the request, all right? But in this example, server's not going to do anything until the client actually requests something. It's just going to sit there. Okay, so that's the server. The client, we're using the same imports here. And we just have to build a simple graphical interface. So I'm going to use a JFrame, a JText area, and JScroll pane to display the quote in, and a J button that I'll click on to connect, which will simply call this connect function down here. So remember that main is always called first. So what happens? We call build GUI once main is called. And what does that do? That takes our globals up here, right? The J button, the JFrame, the JScroll pane, the JText area, and we're just going to build our JFrame, set the size, set the location, set the attributes, and add everything into the window. Now once we've done that, we built the GUI, we also need to add action listener to our button, so we can listen for mouse clicks on the button and then go do something, in this case called the connect method. So that's what this function does. Main window action comes down here to main window action. We're just going to add a new action listener to our button bConnect, and the action performed event handler is going to be calling the connect method that you just saw up above, and we'll go back to. So all that's done, we're going to take our JFrame and say set visible true, so it makes it visible and we can see it. Okay, so that hopefully explains the graphical part of our client program. And now this is sort of the meat and potatoes part, or at least the part we're interested in, right? The socket part, the DatagramSocket part. All right, so here we're going to build or instantiate a plain old DatagramSocket, so we can connect to a server socket and communicate via UDP. We're just going to call it sock. All right, we're going to use a array of type byte, and again, it's just going to be a buffer. And the size will be 256. Okay. In a similar fashion to what we did with the server, we want to get or specify in this case the IP address. So we're going to use an inet address object. We'll call it IP address, and we're going to go call the function get by name on inet address. And this is just the loopback. Okay, so we're connected to a loopback here, 127.0.0.1. Just my host for testing. And server here doesn't really care. It's just listening, waiting for a connection. But the client here, it needs to know the IP address of the server, so it's connecting to the loopback, because when I test it, I'll be running the server on the same host that I'm running the client on. Otherwise, I'd point that to whatever web server that I ended up installing my server on. Okay, so that's variable. But DatagramPacket, we're just taking and building a new Datagram packet. We're going to call it packet, call it what it is. Again, we need the IP address, we need the port. We need to make sure that the port that the client is trying to connect with is the same port that, if you will look here, our server is listening on. Okay, so it's listening for the port there. There's our new DatagramSocket 444. Server's listening at 444. Client's trying to connect with 444. And also the client needs to know the address, the IP address of the server. In this case, loopback, because it's being tested on my local machine. So, all right. That being said, now we're going to send a packet. So the client's going to send the packet to the server. And remember, the server was waiting for that. Remember, it's just sitting there waiting for the client to request a quote to respond to the client. So it's waiting for that event. And here's where that event is taking place. It's sending the packet. I keep switching back and forth between client and server. I hope that's not confusing. So it sends it, and then what happens? All right, we're going to instantiate or build a new Datagram packet. And then what are we going to do? We're going to receive. Here we were requesting the quote from the server. Server got that, sort of like this handshake process. And now finally the server is going to send us back the quote. But we need to receive that quote, that string of text, via the packet that we instantiated. All right, so our DatagramSocket and our Datagram packet, we call the receive method. And then once we do this, now we want to build a new string and get the data from the Datagram packet object using its length attribute, getLength. So we're just going to take a string here, we'll call it message, and we're going to instantiate or build the new string. And in the constructor of this string, we're pulling the data out of the Datagram packet that got sent to us from the server, and we're getting the length. All right, so we specify how long the string is to be in the constructor. Once we do that, all we have to do is display it. And in our GUI, we have a JScroll pane and a text area, and I don't want to erase the text that's already there, so I'm not going to call the method setText. I'm going to call the method append. So I'll just keep adding the text and adding the text and adding the text to what's already there. Okay, and we're just going to take our text area and do that and display that, and then we're going to close the socket. Okay, so that's pretty much what it does. All of these quotes here. Go over here to the server. So let's see it in action. First, we need to run the server. So we'll sit there and listen, launching quote of the day server thread, waiting for client to connect. And now we need to launch the client. All right, so we'll launch the client over here, and I'm going to come back and show you the output of the server and the client so you can see. So down here, this is what the computer running the server would see. Up here, this is what the computer running the client would see. I click connect, and it sends me a quote. Connect, and another quote. And I'm just going to keep going all the way, and I'll scroll down here too so you can see the console. All right, 7. All the way till we get to the last quote, which I think was 19. And then it's, okay, fresh out of quotes, may it have some time. And at that point, it just serves the time. But you can see how that works. Multicast socket objects are created on the client side to receive UDP packets that a server broadcasts to multiple clients simultaneously as a group. The multicast socket objects in each client passively listen to UDP traffic emanating from the server at regular intervals, and the server does not wait for requests from any clients before broadcasting its packets. In other words, it simply sends data whenever it wants to independently of any clients connected to it. This kind of UDP client-server relationship is ideal for applications such as live internet video and audio broadcasts and internet radio stations like Pandora, where a great deal of data must be sent from a server to multiple clients without the added overhead that TCP would add if such traffic had to be reliable and each packet had to be accounted for. UDP multicast socket objects involve communication with an entire group as opposed to TCP socket objects that involve communication with individual IP addresses. All UDP multicast clients create multicast socket objects and listen on the same port at the same multicast IP address for broadcasts from the server. After creating a multicast UDP connection, clients will use the multicast socket's join group method to join themselves to the group identified by the INET address object's call to the getByName method. This will become more clear as we look at it in code. Whereas the client must use a multicast socket object to listen for server broadcasts, the server itself can use both multicast socket and DatagramSocket objects to broadcast its UDP datagrams. Unlike the client, the server can use datagram sockets since the UDP and address information is transmitted within datagram packets regardless of the type of socket object being used by the server. This example is somewhat like our previous example, with a few small changes. And first off, on the client, we're using a multicast socket instead of a datagram socket. And also on the server, whereas before, typically in our projects, we would set up the server to listen on a socket. It would wait for a client to request something, and then once it received a request from the client, it would send that client data, packets, whatever. Well, in this example, we're not going to do that. In this example, we're going to tell the server to just start broadcasting. And keep broadcasting and not wait for a client to request anything, but just keep broadcasting that data over and over and over, regardless of who's listening or not listening. And why would you use, why would you do something like that in a project? Well, that is actually perfect for something like maybe sending large amounts of video or audio. Like say if you're doing a live video cast or an internet radio station like Pandora or something. Where you don't necessarily want TCP connection-oriented traffic eating up all your bandwidth, and you can get a lot more bang for the buck just using UDP and just broadcasting regardless of who's listening. And if a few frames get dropped, a few packets get lost, who really cares? You just want to stream that data out as quick as you can. So maybe that kind of gives you an idea of why you might choose to code a server and client this way, as opposed to the previous examples that we've gone over where we would simply wait for a client request. So two major changes. Again, the server is no longer going to wait for requests. It's just going to start broadcasting. And we'll take a look at the code and see how that works. And also the client is using a multicast socket and not a datagram socket. Now, the server is still using a datagram socket. It could use a multicast socket. Either one doesn't matter because the information that we need, the port, the IP, the multicast addresses, is sent in the datagrams itself, the DatagramPacket objects. Okay, so let's start out and go through the code real quick. We have the same three imports here, and we're extending thread. Remember, if we extend thread, then not only does quote multi-server function as a thread object and inherit all of its methods, but the run method is abstract, and therefore we have to include it since it's extending thread. Okay, and we have our same global integer and time interval here, which we'll use when we code the broadcast process for our server. So maybe that part's a little bit different there. But the same array of type string. These are all our pirate quotes. Nothing's changed there. The same main method as before. Nothing's really changed here. So let's look at the program flow. What happens first? Well, the main method gets called. So what do? We instantiate or we build an instance of the class, which then calls the constructor, which will then build an instance of our global datagram socket. Remember, we had our global datagram socket up here? Sock. All right, so down here we're building it, and we're going to listen on port 444. When we do this, we're going to just throw some feedback on the computer that the server is running on. In the console, we're going to say launch multiclass quote of the day server thread and waiting for client to connect. Okay, so all that happens, and then we're going to go call the start method. Well, remember when you call start on a thread object, it goes and immediately executes the run method. So then all this code here would be executed. Well, what happens in the run method? Much like we did before, we're going to build an array of type byte, a buffer. We'll set it to 256 as the size, the number of bytes. Then we're going to build a string called message, and we're going to call the next quote method. The next quote just does the same as it did before. It's got a temporary string, and when it's all said and done, at the end of the function, it returns a string. And what happens? Well, it builds a data object, and we just have to be careful we don't get array index out of bounds error by going past the last element in our string. I think there's 19 here, so we want to be careful not to go to 20, or it would create an exception and could crash our program. So that's what we're doing here. If quote count is greater than pirate quotes.length, the length of the array minus 1, then we're just going to display, hey, fresh out of quotes. May it have some time. We're going to convert our date object up here to a string with its string method. And this would be sent to the client. And then on the server side, this would be displayed in the console on the server. So that way we also get feedback on the server side. All quotes were served, dishing out some time. If that's not the case, however, we still have plenty of quotes left and we can serve out some quotes, then we're going to do that. We're going to concatenate the number there using our counter object, and then the appropriate quote, and assign that to message. And eventually that will get returned and sent to the client. And then on the server, we're just going to display serving out quote number. And so when we run it, you'll be able to see on both the server side output and the client output what's happening as these quotes are served out. So back to the run method. That was only the second line here inside of our try block. So that's what happens. Next quote is called. The result is assigned to message. Then with message, we're going to call get bytes to get the number of bytes in that string. It's unknown, at the time, but we'll figure it out. We're going to store that in buffer, our array of type byte. And then on the server, what we need to do is we're going to instantiate an inet address object. We'll call it IP address group, since multicasting involves communication with the group. And we're going to use the getByName method, and we're going to specify a multicast class of address. That needs to be 224 or above. Why? Well, remember how classful IP addressing works. Class A is 1 to 126. The loopback is 127.0.0.1. Class B is 128 to 191. Class C is 192 to 223. And then multicasting, Class D, starts at 224. So here's the thing. If I were to use a Class A, Class B, Class C, or the loopback or something, I would get an error because those are not multicast addresses. So when I do multicasting, I have to use the appropriate multicast address or an address in that multicast range, that Class D range of IPs. So there are other videos on that, and you have your good friend Google if you need to know more about that. But just remember that, since you're multicasting your UDP traffic, you need to choose something that's in the multicast range. Okay, so once I do this, I'm going to instantiate or build a datagram packet. And when I do that, I'm going to pass in this case, the multicast IP address and the port that the server is listening on. So this will be the group that the clients will want to join, and this will be the port server is listening on the port that they'll want to implement. Okay, when I get all done with that, I'm just going to go send a packet. I'm not going to wait. In this case, I'm not waiting for any client to make a request here. I took the message that was in the string, all right, and I am holding it now inside of my buffer, in terms of bytes, and I'm constructing a packet with those bytes in the packet, all right. So it's the buffer and the length of the buffer, and I'm sending that packet. I'm just going to send it on its way, all right. Bam, all the way down to our 224.0.0.1 group, our multicast group over port 444. If clients are listening, they'll get it. If clients aren't listening, they'll miss it. Doesn't matter, doesn't care. This is not TCP, it's not connection oriented, it's not reliable. It's just hit or miss. But that's pretty much what you get. Think like a TV broadcast or something. We're talking broadcasting as opposed to connection oriented traffic where we have to make sure that every packet gets there and it's there in the right sequence. Well, UDP and multicast don't really care about that. So because of that, we have to code the server a little bit differently. And then just so that we have time to see what's going on, otherwise it would just happen too fast, I'm going to pause for a little bit. And we could, wait some random interval, times the amount of seconds that, in this case, 6,000 milliseconds would be 6 seconds. All right, so we could do that. Matter of fact, I'm just going to let me do this here, and I'll try to make it so that it's not so that it's not too fast and not too slow. I guess we'll be able to see. So anyway, it's going to pause for 3 seconds, and then what's going to happen? Well, it's going to do the whole thing over again. Remember, we're all this code's inside of a while true loop, so then we're just going to do the whole thing over again. So 3 seconds, and then another quote, and 3 seconds, and another quote, and 3 seconds, and another quote, regardless of who's listening. So hopefully that explains the server class. Now let's go look at the client class. In this case, again, same as before. Here's our globals for the objects that go on our graphical interface, our JFrame, and our JButton, our JScrollPan, our JText area. Here's the main method called automatically, which is going to turn around and call build GUI. And build GUI takes care of taking our JFrame and adding our button, our JButton, and our text area and our scroll pane and configuring them appropriately. And then also we have to add action listener to the JButton connect, right? So that it'll listen for mouse clicks, and that's all this does. Main window action. We call it, it adds action listener, and the event handler action performed. That's just going to go call the connect method. So nothing's really changed there from the previous example. What has changed, if you look in the connect method, instead of a datagram socket, now we're using a multicast socket. We have to listen on the appropriate port, and we're just going to listen. These broadcasts are coming in, we're going to listen. And not only do we need to listen on the right port, we have to join the right multicast group. So we're going to call the getByName function on the inet address object. And once we do this, then we're going to use the method joinGroup on our multicast socket, and we're going to join group and pass in our IP address. Okay. Once we do that, here we just have a datagram packet. We're going to call it packet, and we're going to loop. And in this case, I'll just grab like 3 quotes, or like the next 3 quotes whenever we connect. And we could play with this. We could change that variable there if we want. But again, I have an array of type byte to act as a buffer. And when I do this, I'm going to instantiate or build a new datagram packet. And it's going to be of, in this case, 256 bytes and the length of that array of type byte. And then I just want to receive the data being streamed from the server, store it in that packet. Okay, when I do that, I need to then convert it. So I'm going to instantiate or build a string object here, call it message. We're going to use a new keyword, build a new string. I'm just going to fetch or retrieve the data out of the packet by the length of the data in bytes. Alright, so that will construct that string, or instantiate that string. Finally, I just want to append it to my text area and my scroll pane. And I want to use append because I don't want to erase the quotes that were previously there. Alright, I could use setText, but then that would just constantly erase everything, not what I want. So I'm just going to append it. Alright, so we're going to do that 3 times in a row. We'll get the next 3 quotes whenever we cut in, which will be completely at random. Okay? Because remember, the server is going to broadcast regardless. It's not going to wait for us to request anything. But whenever we just kind of like if you imagine you're flipping the channels on your television set, if you have cable or something, and I haven't had cable in years, I just use the internet. But just imagine a live broadcast, right? You don't. It's not like video on demand, but you start watching it at the point where you actually get to that channel. All right. So it's kind of the same situation here with multicast. So finally, when we're all done with that, we're going to leave the group, the multicast group, our IP address 224.0.0.1, and then we're going to close our multicast socket. All right. So that sort of hopefully explains the differences of how the server and client work in this example, and let's see how it looks. So I'm going to run our multicast server, and notice it's just broadcasting. It's not waiting for a client to request anything. So now I'm going to run the client, and I'll display the output on the server. So you can see, even though I haven't made the connection yet, it's just broadcasting regardless. So I'm going to connect to it, and we'll basically get 3 quotes in a row here. Remember, our loop on the client side was 3. All right, so we received 3, but where we cut in, when we made it to the channel, it happened to be on broadcast 7, 8, and 9. So it's not reliable. We missed quotes 1, 2, 3, 4, 5, and 6, and where we came in, it was 7, 8, and 9. But you can just kind of see how that works. and the server's still broadcasting. Even when I shut the client down and I'm no longer listening, server is still doing its thing until we were to stop it. So sort of the idea behind multicast, multicast socket objects and multicast traffic.